guys, this is the second video on writing equations of the trig function based on the graph. I decided to do 3 videos instead of one long video because I want to keep every video to about 5 minutes, so that way it gives me enough time to kind of explain to you what is happening, and it will also make sure that you guys don't fall asleep after watching the video. So looking at this particular graph, we notice that this could be a possible secant or cosecant graph. Now I'm going to go with cosecant on this case. Well, I'm going to write the secant graph as well, but I'm going to start with cosecant because the way the graph is positioned, it is actually perfect for a cosecant graph. Remember, the cosecant is the reciprocal of sine. So if you guys remember the sine graph, it started with a hill and then a valley. So if it's the reciprocal of the sine graph, you would notice that this particular hill here, that we call the first hill here, when it's taking the reciprocal, if you remember the cosecant graph's parent function, it does become an upward-facing parabola, followed by a downward-facing parabola. And cosecant graph has a vertical asymptote starting at x equals to 0, which this graph does as well. So if I start with the cosecant graph, then I actually don't have to worry about phase shift because there is no phase shift. My vertical asymptote did not move. Okay, so from here, the next thing we need to determine is where is the center or the equilibrium of this particular graph. Because even though cosecant and secant has no amplitude, I do still need to know where the center of the graph is to determine what the leading coefficient in my A is going to be, because that's going to help me determine if there's a vertical stretch or not. So taking a look at this, I do notice there's a local maximum at -4, and there's a local minimum at 2. That means the center of the graph should be somewhere in between those 2 points. So if I take the midpoint formula between y equals to 2 and y equals to -4, I will get y equals to -1. Now, if you guys remember the midpoint formula, it is the average of the 2 values. So y equals to -1 will be the center of my graph. And because the center is at y equals to -1, I can clearly see the distance from y equals to -1 to this 2 is 3 units up, and this one is 3 units down, which does make this the center, but also tells me my vertical stretch is by a factor of 3. Since I started with a upward-facing parabola and a downward-facing parabola, that tells me there's also no reflection across the x-axis for my cosecant graph. If there was a reflection, then I would have started with a downward-facing parabola followed by an upward-facing parabola. Because of that, I think now I am actually, oh wait, we forgot period. Okay, so let's take a look at the period. So I have a vertical asymptote right here at x equals to 0. And as we know, a cosecant graph does have 2 curves to finish the whole entire period. So if I notice, the third vertical asymptote of this whole entire thing ends at pi over 2. So that tells me I actually have a period of pi over 2 for this particular graph. Now, the parent function of the cosecant graph, which is the reciprocal of sine, has a period of 2 pi. And pi over 2 is a quarter of that, so that tells me my x value should have a coefficient of 4 in front of it, because we find the new period by taking the old period divided by whatever the coefficient in front of your x value is going to be. So this is now enough for me to write my function for cosecant. So again, there is a vertical stretch by a factor of 3, but no reflection. This is cosecant. And we notice there's no phase shift because I still have vertical asymptote at x equals to 0. But there is a period change from 2 pi to pi over 2. So that means I should have a 4x here. Now, the center at y equals to -1 also tells me now there's a vertical shift of the whole entire graph down 1. So I need to make sure I add the -1 in the back to accommodate for that. So that's how I would write a cosecant curve for this particular function. Now, if I decide to write this for a secant curve, so let's do that right now. And I want to make sure I change this to a different function. Let's call it wx for Wilson. Anyway, so I have a couple choices. If I decide to write this as a secant curve, then if we remember, secant curve starts with a point with the center or the vertex of the first curve, the upward-facing curve, being on the y-axis. Okay, so for the parent function, the secant curve actually has a point at 0, 1. So if I notice the vertex of that upward facing parabola is now at pi over 8, 2. That tells me there is now a phase shift for my secant curve from 0 to pi over 8, which is the right shift of pi over 8. Now, because secant and cosecant curves are so similar, then for the same graph, their not amplitude, but their vertical stretch and their vertical shift should be the same. So should their coefficient in front of the x value, because we're talking about the same graph. Just like we say the difference between a sine and cosine curve is basically a phase shift, that's pretty much true for cosecant and secant curve. Because, again, they're reciprocal functions, so they do carry on certain characteristic of the original function as well. So with that in mind, again, I'm picking this particular point as my starting point. So this is my starting point. Because I'm picking this as my starting point for my secant curve, it is still a upward facing parabola followed by a downward facing parabola, which means I still don't have to worry about the reflection across the x-axis. So my leading coefficient of the 3 is still positive. Except this time I'm talking about secant. And there is a phase shift. We just talked about it. There's the phase shift from 0 to pi over 8, which is shifting to the right. So it's x minus, again, let me find my pi. X minus pi divided by 8. And we're still talking about a vertical shift down 1. So there it is. And keep in mind, guys, you can always verify your solutions by using your graphing calculator and putting it in. Just make sure you are in radian mode when you're graphing, or else you're going to get really confused as to where you're looking at. But you can always verify your equation by graphing what you propose is the correct function into the graphing calculator and see if that matches the graph that's given to you. Well, hopefully this is helpful in helping you guys both graphing and writing equations of secant and cosecant. And again, let me know if you have questions. You can you can still find me on Remind for tutoring. Okay? I'll see you on the next one. Bye.